Okay, guys, this is lesson three of lesson three for absolute value functions. So, in the previous video, we looked at solving an absolute value equation graphically, and then we looked at solving one algebraically. In this video, we're going to look at solving an absolute value inequality. So, to help you understand this, I've given you an expression. The absolute value of x is less than 3. Now remember, absolute value is always positive. So let's look at a number line to see some answers that fit. What numbers would make this true? So let's look at, say, -5. So if I take the absolute value of -5, what do I get? I get 5. Is 5 less than 3? No, it's not. So I know this is not true. If I did -6, the absolute value of -6 is 6. So that's not true. Well, let's go the other way. Let's start at -4. The absolute value of -4 is 4. And 4 is not less than 3, so that's not true. How about the absolute value of -3? Well, the absolute value of -3 is 3. Is 3 less than 3? It's not. Excuse me. But however, I notice that it's the absolute value of -2 is 2, which is less than 3. So I know -2 is a correct answer. How about -1? The absolute value of -1 is 1, so that's true. 1 is less than 3. 0 is less than 3. 1 is less than 3. 2 is less than 3. 3 is not less than 3. And 4, 5, and 6 are not less than 3. So what makes this true? Well, -3 doesn't make it true, but I'm going to put an open circle on it because any number between -3 and 3 will in fact make that true. So we see that the numbers that will make that true are between -3 and 3. Everything in between -3 and 3 makes that statement correct. So how do I write that as an answer? I could say that my answer is between -3 and 3. That is my solution. So all the values between -3 and 3 makes this statement correct. So what we see, if it's less than, we form what we call a conjunction. I'm sorry, that's not a conjunction. What we see is that every number between -3 and 3 makes it true. So that is how we get our first set of answers. So we can see from this, anything that's in that absolute value symbol between -c and c is going to make it true. And that's what we saw from this. Everything between -3 and 3 makes it true. Alrighty, let's do greater than. So we say this is an and. Less than is and. So let's look at greater than. So I'm going to start the same way. If I take the absolute value of -6, that's equal to 6. Is 6 greater than 3? It is. The absolute value of -5 is 5. Is 5 greater than 3? Yes. The absolute value of -4 is 4. That's greater than 3. The absolute value of -3 is 3. 3 is not greater than 3. It's equal to 3. So I'm going to put an open circle. And then if I look at -2, the absolute value of -2 is 2. That's not true because 2 is not greater than 3. 1 is not greater than 3. And so we see that the next place where this is true is at 4, because 4 is greater than 3, 5, 6, and 7. And I'm going to put an open circle on 3. So we see that all the numbers less than -3 is true, and all the numbers greater than 3 is true. So this is an or. So when we see greater than, it's or. Less than, we're going to have an and. Greater than, or. So how would I write this answer? This answer would be -infinity to -3 parenthesis, parenthesis, union 3 to infinity. Or I could say, probably a better way of saying that is that x is less than negative 3, or x is greater than 3. And that gives us our second situation. When we have greater than, we're going to break that up into two statements. One is it's going to be less than the negative value of c, or greater than the positive value of c. Okay, so when we have less than, we're going to write it as a conjunction. It's between those two numbers. When we write it, when it's greater than, it's a disjunction, I think. And it is, we write it in two separate inequalities. Less than the negative value, greater than the positive value. And that's the same applies to less than or equal to, greater than or equal to. So here's the steps. We're going to isolate the absolute value expression just like we did in the previous video. Move the absolute value expression to the left side of the inequality. So we're going to rewrite the inequality to an and or an or statement. So we're going to do and if it's less than or equal to. We're going to do or if it's greater than or equal to. We're going to write an or. And then we're going to solve for x. Alrighty? So let's do a couple of examples. In this first example, we have less than. So remember, if it's less than or equal to, we're going to write it as negative c is less than whatever's inside the absolute value. It's less than c. Okay? So because it's less than, we're going to write negative 2 is less than or equal to x is less than or equal to 2. And really, that's all we can do for that. So how do we graph this? Well, we're going to have to start with negative 2 and 2. And our solution is going to be a closed circle on negative 2, a closed circle on 2, and shaded in between. Greater than 5. It's greater than, we're going to have ax plus b is less than negative c, and ax plus b is greater than c. So since this is a greater than, let me erase that because it's not greater than or equal to, it's just greater than, then we're going to write this as x, what's inside the absolute value, x is less than, make that a negative, or x is greater than, keeping that a 5. And so what does that look like? This is my 0, and if I go up by 2, so this is 2, 4, 6, 2, 4, 6. So 5 is going to be in the middle here, and it's going to be an open circle, shaded, and 5 is in the middle here, open circle, shaded. Okay? So this one is greater than or equal to. So remember, if it's greater than, there's an or. Greater there's an or. So this is going to be x minus 2 is less than or equal to negative 1, or x minus 2 is greater than or equal to positive 1. Remember, for the first one we write, we flip the inequality and we change the sign if it's greater than. So then this is add 2 to both sides. X is less than or equal to 1. Add 2 to both sides. Or x is greater than 3. So set up our number line. Let's make this 0. So we have 1, 2, 3, 4. So x is less than or equal to 1. So that would be a closed circle on 1, shaded to the left, a closed circle on 3, shaded to the right. Okay? we have less than, but before we can do anything, we have to get the absolute value by itself. So the first thing we have to do is subtract 2. And we have the absolute value of x plus 1 is less than 3. All right, because it's less than, we have to set up a conjunction. We take the opposite of 3, negative 3 is less than x plus 1 is less than 3. So we're going to subtract 1 from all 3 sides, and we get negative 4 is less than x is less than 2. So because it's less than, negative 1, 2, 3, 4, negative 4, and this is 2. So we're going to have open circle, shaded in between. Okay, let's do another one. We have greater than, but before we do anything, we have to get this absolute value symbol by itself. So we're going to divide by 3. We have the absolute value of x plus 1 is greater than or equal to 4. So because it's greater than, we're going to set up 2 inequalities. The first one, we flip the inequality and we flip the sign. The second one, it stays the same. So solving that, I get x is less than or equal to negative 5, or x is greater than or equal to 3. Okay, so I'm going to set up my little handy dandy number line. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it's less than negative 5, less than or equal to. So there's a closed circle shaded to the left. And on 3, there's a closed circle shaded to the right. Okay, let's do one more. This one, we have to do a whole bunch of stuff to eliminate it to get the absolute value by itself. The first thing is to subtract 3 from both sides. So we get 2. The absolute value of x minus 3 is less than 2. Then we're going to divide everything by 2. So we end up with x minus 3. The absolute value of x minus 3 is less than 2. So once again, we have to set up our inequality. So we have negative 2 is less than x minus 3 is less than 2. Then we add 3 to all sides. So we get 1 is less than x is less than 5. That's 1, this is 2, 3, 4, 6. So between 1 and 5, and it's an open circle on each of those and shaded in between. Okay, boys and girls, what I want you to do is pause the video, and I would like for you to do the last 3. Okay, welcome back. So hopefully this is what you found. We have, this is greater than, so we're going to have 3x plus 5, and the absolute value is isolated, so we don't have to do anything. We flip the inequality and we flip the sign, or 3x plus 5. We keep the inequality and we keep the sign. So I subtract 5 from both sides. I get 3x is less than or equal to negative 16. Divide by 3. So I get x is less than or equal to negative 16 thirds. And 16 thirds is 5 1/3, 5.33. Use your calculator. So for the next one, I'm going to do the same thing. I subtract 5 from both sides. I get 3x is greater than or equal to 6. X is greater than or equal to 2. So I have negative 5 1/3 and 2. So 5 1/3, let's see, I'm going to start this. Let's start it about right here. So negative 5 1/3. So this is 1, 2, 3, 4, and 6. So 5 1/3, negative 5 1/3 is going to be somewhere And here we can just estimate it. It's closed circle, closed circle. So somewhere in here we're going to put a closed circle. And then we go to 2. And we put a closed circle on 2. And it's less than negative 5/3. So that means we're going to shade to the left. It's greater than, so we shave to the right. Shade to the right. Alrighty, now this one's a little tricky. I probably should not have given you this one on your own because you probably got it wrong. So we have the absolute value of 2x minus 1 is less than negative 8. So what do we know about absolute value? Absolute value is always positive. So the absolute value of this can never be less than negative 8 because it's always positive. Therefore, there is no solution. Because this will never be, if we take the absolute value of it, it's always positive, so it's never going to be negative. Therefore, it can never be less than a negative number. So if we look at 9, again, I probably should not have given you to do this one on your own. We get x plus 8, the absolute value of x plus 8 is greater than or equal to negative 7. Now this is different. What do we know about this? This is always positive. This is always positive. And so all positive numbers are going to be greater than a negative number. So the solution to this is all real numbers. Because it doesn't matter what we put in for x, it's going to come out positive. And positive numbers are always greater than negative 7. So if any number I put in there, let's say I put in negative 100. So negative 100 plus 98 is negative 92, but the absolute value of that is positive 92, and a positive number will always be greater than negative 7. So this is all real numbers. Sorry about that. Oh, there's more. All right, so pause the video and do problems 10 through 12. There are no tricky ones on that one, and come back and we'll get an answer. Okay, welcome back. Let's do problems 10 through 12. This is less than, so we're going to have negative 3 is less than or equal to 2x plus 5, which is less than or equal to 3. Subtracting 5 from all sides, we get negative 8 is less than or equal to 2x, which is less than or equal to negative 2. So we get negative 4 is less than or equal to x is less than or equal to negative 1. So negative 4, if I choose my 0 here, if I make this 0, so this is 1, 2, 4, and this is 2, and then 4. Right, so it's going to be less than or equal to, so closed circle, and negative 1, which is closed circle. So my solution is between those two. Greater than 1, so it's greater than, so we're going to have 1/3 x minus 4 is less than or equal to negative 1. And I'll write the other one down here. 1/3 x minus 4 is greater than or equal to 1. So solving this, I'm going to subtract 4 from both sides. I get 1/3 x is less than or equal to negative 5. I have to multiply by the reciprocal, which is 3 over 1. So I get x is less than or equal to negative 15. Here I'm going to add 4 to both sides. So I have 1/3 x is greater than 5. And then x is greater than or equal to 15. It's unusual that they both will give me the same thing. Did I do that right? Negative 1. Oh, I didn't do that right. When I subtract, I have to add 4. Sorry. And that's going to give me 3. Sorry. Bad math. All right, so we have 1/3 x is less than or equal to 3. So that makes x less than or equal to 9, because we multiply by 3 over 1, the reciprocal, and we get 9. And here we have x is greater than or equal to 15. So let's set this as 0, and we're going to count by 3. So this is 3, 6, 9, 12, 15, 18. And it's an or, so it is less than or equal to 9, so close circle. Greater than or equal to 15, close circle. And there we go. Alrighty, for this one we have to get the absolute value symbol by itself first, so we get 2x is less than 2. So less than, so we have negative 2 is less than 2x is less than 2. I'm sitting outside, so that's the noise you just heard. We're going to divide everything by 2, so we get negative 1 is less than x is less than 1. So if this is 0, I'm going to, it should be an open circle, because it's just less than, so I'm going to do an open circle, and shade in between. Okay, that's it for lesson 3. In this unit, I know that's a lot. Try to do as much as your homework as possible.